Hi, this is Lori, and this is my homework for Paul McWhorter's Raspberry Pi course. This homework covers lessons 25 and 26. In these lessons, we're working with the DHT-11 temperature and humidity sensors, and then adding in the LCD display 1602. I'm also including using the DHT-22 temperature and humidity sensor. And then I recently purchased a pretty fancy sensor that does temperature and humidity and some other stuff called the BME 680. And I brought that into the homework because I was curious about how it compared to the cheaper DHT-11 and 22. Here's the three sensors that I'm using. The DHT-11 that we got in our kit. I happen to have a DHT-22 as well. It's supposed to be a little more accurate and maybe a little more precise than the DHT-11. And this is the BME 680 that I've gotten from Pimoroni. Now you can see the price tags of these are definitely different. The DHT sensors only do temperature and humidity, whereas the BME 680 does temperature, pressure, humidity, and can measure an indoor air quality as well. So that's why I was interested in having one of these for my house to see if I could put something like that together. But as I started to experiment with the 11 and then the 22, noticing that I was struggling to get good data from them routinely, I put in the BME 680 just to see was I struggling to get good data with that one as well. So that's how they all ended up in my homework. And this is why my homework is so late, because I go down these rabbit holes and start comparing things. But anyways, that's what I did for this homework. Here's the circuit I'm using in this homework. First, I just showed that the 11 and 22, they're already on breakout boards. You can't get them not on these breakout boards. And it made me question whether we needed this 10K resistor that Paul showed us to put in. And I looked at the SunFounder documentation, and they also recommend putting that in there on our reading pin here, our output pin. So I looked at the back, and I can see that there are 5K resistors on the back of this breakout board. And so I was thinking that maybe we didn't need this 10K resistor, and kind of reading around it, it seemed like we probably didn't. But as I started experimenting with these sensors and realizing that I was getting slightly better data when I have these in place, so I've left them in the circuit. But it's kind of marginal how much help they give to making sure we get valid data. Here's my BME sensor as well. And you'll notice that both my BME sensor and our LCD screen use I2C or I2C pins. And so they're both actually plugged into the I2C pins for our Raspberry Pi. But they both have different I2C addresses. So the Pi is able to handle both of them at the same time. So that was nice. And then here's my two buttons. And what I'm going to use these buttons for is, the red one is to change from Celsius to Fahrenheit and back. But this blue button is to switch between which sensor is being displayed on our LCD. And this is my final slide, just showing some of the results I've had. So I did get kind of hung up on this homework for quite a while and spent a lot of time on it, and then got distracted by the Raspberry Pi Pico course, and that's where I kind of paused on this and took a big break from the Raspberry Pi itself. So when I use the DHT-11 and 22, I'm finding that the invalid rate is pretty high, and it surprised me because I just didn't remember that when we used this same sensor with the Arduino. So I wrote some programs to kind of keep track of that invalid rate and just see how high it really was. And so you can see here when I run it, I get about a 30% invalid rate when I don't have an extra resistor, and about 20% when I add one in. And then I switch to the other Pi GPIO library to control the GPIO pins. And when I tested both the 22 and 11, I got the exact same results. So they were always invalid or valid at the same time, which I thought was also very interesting. I don't fully understand why that happens, but then I got about a 36% invalid rate, and putting the resistor back in, I got 23. So again, over, 10% improvement. So that's what I saw, and as I read around a lot about this, trying to understand this more, I did read that you don't want to read these sensors too frequently, so I'm only reading them every 2 seconds when I do these calculations, and also when I'm doing the actual project, I made sure I wasn't reading these too frequently, so I don't think that's the reason why the invalid rate is high. I am curious, other students had a similar experience with these two sensors. Now, when I used the BME 680, I never had any problem with invalid data at all, but of course that's a much more expensive sensor. Well, let's get on to the programs and see how I wrote them and how they run. So this is the program I adapted that Paul helped us put together to read our DHT-11. So we'll use that library that we put in during the class and get that all set up on pin 17 for me. And then I did a little bit of an adaptation to the program because I wanted to keep track of how many bad readings I gave so I could give those statistics I showed in the slides. So I'll start those off at 0, and then in the while true loop we'll read the sensor. We'll check to see if it's valid. If it's valid, we'll go ahead and print out the result. If it's not valid, then we'll print bad reading to the screen, and we'll increment the number bad by 1. And no matter what, we'll always increment the number of total by 1, sleep 2 seconds, and come back around. And then when we leave the program using our keyboard interrupt, we'll print out the results so we can take a look. Now we'll go ahead and give this program a run and kick it off. And we're off to a bad start. There, we got one bad reading. Now everything's coming along, looking good. And yeah, like I said before, I just don't remember getting this many bad readings from using this sensor with an Arduino. And I also don't remember even checking for that, so I'm going to have to dig back in there, but this homework is so delayed as it is. It's just time to record some stuff and move on, I think. But I definitely fell into a rabbit hole with these sensors. All right, so let's go ahead and stop it. And you can see this is how I got the data that I shared with you. I have have the counters in there, and you can see this is how I got the percent invalid rate from the run. Here's the program I used to connect up both the DHT-11 and 22. And I also was very interested in trying the other library, the pigpio way of addressing the GPIO pins rather than the pigpio way of addressing the pins. They were a little bit different, and was wondering if maybe using those might improve the results. To do that, you got to start that pigpio daemon using a sudo. Once you do that, you can bring in the library that has those two sensors set up. So we'll import them, and we'll initialize them on pin 17 and 22. And here you can see the results that come out of that particular library when we do a read. And we can get both of the sensors when we read them. And we get both Celsius and Fahrenheit and humidity. And then it also gives us whether the result was valid or not. So I'm going to do the same thing as I did with the original library that we've been using in the course. I'll set up the number bad for both sensors and the total number of attempts at reading. And we'll go through the while true loop, and we'll read both sensors. And we'll check to see if they're valid or not. And we'll increment the number bad if it's not valid. You can actually do a little bit more with this library. You can take like up to 5 samples, but I played around with that for a while and didn't find that really giving me much better results. So I just kind of stuck with one sample. And I'll print those 2 things to the screen, both the DHT-11 and DHT-22, sleep for a couple seconds and keep going. And just like we did with the other program, when we do our keyboard interrupt, it'll print out the results for us. Again, this is how I got the results that I shared on the slides. So now let's run the DHT-11, DHT-22 program, and we'll kick that one off. I guess I should point out that I started the pigpio daemon over here previous to this, so this would run. If you start a program that uses it and you don't have that set up, it will complain. So you just need to type that into a terminal to get it started. You can see there's just the basic output as it comes out from that library. And we'll go ahead and, so you can see it's just trues and false in terms of the valids. And they always seem to go together too. I don't often see the 11 and the 22 having different valid and invalid rates. Been pretty consistent between them. So we'll go ahead and close this off. And you can see in this run we got about almost 13% not bad, but we only did 8 runs. So as you saw in the slides, I ran this for longer periods of time to get maybe a better percentage. Okay, well that one's done. This is the program that I used to do the homework as requested by Paul using our DHT-11 and our LCD display and a button so that we can switch the temperature between Celsius and Fahrenheit whenever we press the button. To do that, I decided to use the GPIO0 library to control the button. And the nice thing about that library is it already has interrupts built into it with the button functions, which is really, really nice. If we've been following along in the Pico course, setting up your own interrupts does take some time and effort, and so the GPIO0 library kind of takes care of all of that for you and hides it behind the scenes, which is super cool. So I'm importing the button from that, and then everything that we've been using in the course. Here's my display, and here's the sensor, and I put the button on pin 21. Then I've created a variable that just a way to keep track of whether we should switch the scales. So it'll be true if I want Celsius and false if I want Fahrenheit. Then I went ahead and got my initial reading for the temperature, and it'll just keep kind of going around this small while loop until it gets a valid result. Then I created a little function to use when the button is released called toggle scale. And we'll pass the toggle scale value, we'll make that variable, we'll make that global. And if we press that button or release that button, then we're going to switch the toggle scale to false or true, depending on what we need to do there. And then this is the interrupt that we're setting up with the my button. When it's released, we're going to call the toggle scale function. So again, using the nice interrupt that the GPIO0 gives us. Then in our while true loop, we'll read the sensor, and if the result is valid, I'm printing to the screen that we're updating the stats, just so I can know when we get valid data in. Then if the toggle scale is true, meaning we should be reporting Celsius, then I'll write to the display the Celsius. And otherwise, that means we should be reporting Fahrenheit, and I'll do a quick calculation to get the Fahrenheit from the Celsius reading and send that to display. And no matter what, we'll always write the humidity. We don't need to know what the toggle scale is for that, so we'll go ahead and write the humidity to the LCD. Sleep a couple of seconds and keep going. And if we do a keyboard interrupt, then we'll clear the LCD display and exit the program. So here's the program and the homework as Paul requested, using the DHT-11 and the LCD that we have here. So I have it all set up over here, and I'll go ahead and kick it off. So a little bit behind me here to my side, and I have it just, as you've seen before, printing that there's been an update to the stats, just so I could see, you know, how often is it getting hung up on bad results. So we've got it showing over here. Looks pretty nice. And if I press the red button, we'll switch to Fahrenheit as soon as we get a new data point. Yep. So there we go. That really is fun. I can see why Paul gave us that nice homework to do, because it really puts a lot of concepts together. All right, let's look at the program that I have that puts all three sensors together. And this is my sort of, I guess, extra credit program that I put together to kind of compare and switch between the three different sensors that I have and display those results on our LCD display. Still using a button to switch between Celsius and Fahrenheit, but I put a second button in so that I can switch which sensor is actually being displayed on the LCD. So kind of building on all the programs I used before, I'm going to use the pigpio library to control my pins and the DHT-11 and 22 sensors with this library. And I'm going to use the GPIO 0 to control the button, being able to use the interrupt type function there. And then I'm also importing the library needed to run the BME 680 from Pimoroni. They put a nice library together that makes it super easy to use that sensor. And it's got a lot going on in that sensor, so there's way more than you need just to do this project. And yeah, it's pretty easy to use with the nice libraries they provide. So anyways, long discussion there. But you'd expect something more for a much more expensive sensor, of course. So we'll set everything up, and the buttons, the two buttons that we need, the red button will change the temperature and the blue button will change which sensor we're looking at. Then some of the code needed to set up the sensor. Then here's that function that we put together before for the interrupt. Then I'll also need another one to switch the sensor button. So this one's probably a better way to do this, but it seemed pretty simple. Just checking to see, you know, which sensor do I have in place, 1, 2, or 3, and then if we press the button, then we'll go ahead and switch to the next one, and then keep rotating around 1, 2, 3, and then if it's 3, then it goes back to 1. The way I have it set up is sensor 1 is 11, sensor 2 is the 22, and sensor 3 is the 680. And I start off with it on the 680 because the 680 gets good data very quickly. I thought that would just be easier to start. Then we'll initialize our two interrupts for the temperature button and the sensor button, and connect them to those functions that we put together. And then in our while true loop, we'll just look to see which sensor we currently have set up. And so if it equals 1, then we're going to do the code that we need to do for DHT-11. And then if it's 2, we'll do the code for DHT-22. Very similar. And then if it's 3, do a little bit different code to read the BME sensor and then access the data that we have from that one and write it all out. So pretty simple, but slightly different formats because of the names and all. Uses a little bit different spacing. So I just kind of clear out the screen at the beginning of each of these, so that's why the screen flashes a little bit. And it's probably a little bit better way to do that, but again, I got kind of tired of spending too much time on this homework. So anyways, if we do the keyboard interrupt, we'll clear everything off of the screen and we'll end. All right, so let's demo the 3 sensor program now. I'm going to kick it off. And it starts out, as we saw in the code, on the BME sensor. And it's flashing because every time I have a little bit different format for each one. I was thinking about trying to make it a little less flashy, but again, I'm behind on these homeworks and I need to just move forward. So first we'll just switch the BME to Fahrenheit. That works perfectly. And switch it back to Celsius. Goes right on back. And then we can switch sensor by pressing the blue button. There we go. Now we're to the DHT-11. And we'll go ahead and press it again and switch to the 22. And just for a good measure, we'll check and make sure that we can switch to Fahrenheit. Yeah, it's getting bad data. So it pauses sometimes when it's going through bad data, and it won't update the screen until it gets some good data in. So sometimes you press the button and it can take a little while for it to switch to the other scale. Yeah, so that was a lot of fun, and I think this whole thing sort of showed me that if you really want to do something with temperature and humidity and so forth, you're better off getting yourself a really good sensor and making that investment. You certainly don't have to go all the way up to the 680 that I have, because that does even some more things than just temperature and humidity, but you can definitely get better temperature and humidity sensors. So I'm looking forward to playing some more with my BME 680 on my Raspberry Pi Pico. Well, I hope you enjoyed my homework, and thanks for watching.